Okay, friends, this time we're going from grams of sodium chloride to volume of chlorine gas. Volume is liters, grams is mass. So we're going from 62.3 grams of NaCl, sodium chloride, to a questionable number of liters of Cl2. Now, whenever I have liters, whenever I have volume, there are two things I must have. I must have a temperature and I must have a pressure. And what do you know? Here's a temperature, here's a pressure. So that's what they want. That volume that they want you to end up with needs to be at 18.5 degrees Celsius and 98.0 kPas. Is that STP? Of course you say no. So we know we're going to need to do combined gas law at the end, not the beginning. This grams is not affected by this temperature and pressure. We do it at the end. So let's plug it into our skeleton here. We take 62.3 grams of NaCl and we make our skeleton. Every time we begin, I go from grams, which go down to the bottom. So grams of NaCl on the bottom and moles of NaCl on top. How do I find the molar mass? Because that's this tool, is molar mass. I got to find the molar mass of Na and Cl. So I look at my periodic table and I find that Na's mass is 22.990 and Cl's mass is 35.453. I add those guys together. I get 3, 4, 4, 8, 5, 58.443. So that's the number that'll go here, 58.443 in 1 mole. I look at my coefficients. So I have a formula that's here. I need to check, is it balanced? Well, we know chlorine is a diatomic, so there should be a 2 there. If there's 2 chlorines here, there must be 2 chlorines there. Was that 2 takes care of that? There are 2 NAs, so there must be 2 NAs there. So that's a nice balanced formula. So therefore, I'm looking at my units again. Units always go down from one spot down to the next one. Moles of NaCl and moles of Cl2. This is my coefficient step. And we're changing substances. We're going from sodium chloride to chlorine gas. I look at my ratio and I see that sodium chlorine is a 2, chlorine is a 1. And that's the coefficients right there. Though there's nothing written here, there's a 1. You assume that. Okay, last but not least, am I wanting to end up in moles of chlorine? No, I want liters of chlorine. So again, units go down. I have moles of Cl2 here, and I want liters. I don't want grams. I'm not going to use molar mass here. I'm going to use molar volume. Molar volume is 22.4 liters in 1 mole. What this does is it gives us a number. So we pop this into our calculators here, multiplying all the pieces together. This times this times this times this, this times this times this, and divide the 2 answers. So 62.3 times 22.4, that is 1395. I divide that by 58.443 times 2. I put that in parentheses. And I get 11.93915. I look back to my number here. 62.3 is 3 significant digits. So 1, 2, 3. Look at the 3, ignore the rest. So that gives me 11.9 liters of Cl2. You might say, great, Mr. S, I'm done. And I would say, no, you aren't. Because this is at STP. Is this STP? It's not. So therefore, we must use combined gas law in order to do this problem here. So I'm going to take and do my equation, which is P1V1 over T1 equals P2V2 over T2. Since this number is already at STP, those are going to be my 1s. And the things I'm trying to find up here are going to be my 2s. So therefore, V2, if I solve this equation around for V2, is P1V1 over T1, T2, P2. So let's plug them in. My P1 is going to be STP, and since this is in kPAs, I'm going to make that 101.3. My V1 is the number I just found, 11.9. My T2 is the temperature I want to get to, 18.5. So 18.5 plus 273 is 291.5 divided by T1, that's STP, right? 273. P2 is going to be my 98.0. I pop all those into my calculator. I say 101.3 times 11.9 times 291.5, that's all in one parentheses, divided by another parentheses, 273 times 98, close parentheses, and I get 13.1342, etc. Going back to my 62.3 grams and my 18 and my 98, those are all 3 significant digits. So therefore, I look 1, 2, 3, draw my line, look at my 3, ignore those. The 3 tells the 1, stay where it is. So therefore, my answer is 13.3 liters of CL2.